The electromagnetic spectrum. These are all of the things that are light. They're pretty intense. Everything from radio waves that have wavelengths that could be hundreds of meters, tens of meters long, all the way down to things like cosmic rays, which can have very, very, very tiny wavelengths. Cosmic rays, gamma rays, bad for you. X-rays, potentially bad for you. Ultraviolet rays, infrared, microwaves, TV waves, radio waves. All of these waves are a type of light. And visible light, right here, visible light is a small part of the whole electromagnetic spectrum. It goes from 700 nanometers to 400 nanometers. It's 700 times 10 to the negative 9th meters. That's what a nanometer is, times 10 to the negative 9th. So that's visible light. It only takes up a little bit of it. But looking at this, frequency and wavelength share the same relationship. V equals frequency times wavelength. Except for light, it's c. That constant speed of light is equal to frequency. Any light that we can say has 400 nanometers has a certain wavelength. They're associated that way. Now, this is important to note. As the frequency of my wave increases, so does the energy. So cosmic rays carry more energy. That's why you don't want to get hit by cosmic waves. However, radio waves don't have a lot of energy. Right now, radio waves and TV waves and microwaves are passing through you at a very high rate. That's how we communicate. That's what your cell phone is, and it doesn't really affect your body that much. Whereas, you have to wear the lead apron when you get your X-rays taken, and gamma rays cause cancer, and cosmic rays just cause death. They're bad. So as we get more and more frequency, we get more and more energy. But as frequency increases, wavelength decreases. They go in opposite directions, again, because of this whole F lambda thing. If F goes up, lambda has to go down. So, radio waves have the longest wavelength, shortest frequency. Cosmic rays have the highest frequency and the shortest wavelength. Now, visible light. Visible light is a tiny part of this whole spectrum. It goes from here to here on the whole spectrum. That's not very much. 700 nanometers to 400 nanometers. We're talking 200 nanometers. It's not a lot. But it goes from red, orange, we have yellow here, green, blue, indigo, and violet. That's Roy G. Biv. That gives me the colors of the spectrum, the colors of the rainbow that we see. So, in this Roy G. Biv thing, the red has the biggest wavelength and the lowest frequency. Violet has the highest frequency and the smallest wavelength. That's how light's going to work. An easy way for me to remember that this is the high energy side is that UV rays, which are just right here on the other side of violet, tend to damage your skin. Whereas infrared, not that big of a deal. It might warm you up a little bit. So, this is the electromagnetic spectrum. It covers a lot of stuff. This may be something good for you to write down.